Okay, stats. We're going to finish going through this, I don't know, like your cheat sheet, formula sheet, your grid, whatever you want to call it. We're going to do the rest of that today, and then I am going to have you do some of the problems from the review, which you should have at the end of this chapter. We are skipping over, just as a reminder, we are skipping over section 4.5, but we will come back and do that on Monday when I'm with you, because this is a section that I have to kind of be there to go through. It's not a hard section. It's just I have to run like a random number generator and actually be there in class with you. So that's why we're kind of skipping ahead a little bit. So filling out the rest of this grid, one thing that I want you to do is, I made these numbers up. Sorry. Put this little table at the bottom of your of this grid, because we're going to use this grid to do some of these examples up here. So I kind of maybe tried to like figure out what these numbers were. I think there's 8 girls in the senior class, so I'm pretty sure maybe this number's right. I don't know. I don't know. I just kind of made these numbers up. I know the 9th and 10th grade classes are fairly big, so I tried to make those bigger. But put this grid down. These are boys and girls separated out, 9th through 12th grade. What I can remember of it, I don't know. I know the junior class is really small. I know this is not 100% accurate, but just go with it, okay? I'm also going to put some totals on here. I haven't done that yet. So this is 26 total for 9th grade, 26 total for 10th grade, whatever. 16 and 19 is what I have. Total boys, okay, is, I don't know, 30, 40? 40? 40. And total girls, this is 16, that's 32. 32 plus 15 is like, I don't know, 47. And then that total is 87. Again, I made these numbers up, so don't take this for word. This is 52. I'm checking my answer. This is 35, 52, and 35 is 87. Yep. Okay, my total's right. All right, so there we go. We're going to use these totals and this data to do some of these problems up here. All right, here we go. If you need to pause, go for it to fill that table in. All right. Here we go. Independent versus dependent events. These two go together, and mutually exclusive and inclusive, those two go together. Okay. Independent dependent is when you are doing an and statement, and this is when you are multiplying probabilities. So maybe put that off to the side over here. Independent dependent, multiplying, the keyword is and, that type of thing. Okay, maybe I'll put that here also. Independent, you are multiplying, and this is the formula that you have. You're taking two fractions and you are multiplying them together. Okay. Versus dependent, you're subtracting one from the bottom number. Okay, so like if it was, out of 52 cards before, now it'll be out of 51 because you are doing dependent events. I'm going to put a little star here for important info, because usually dependent is without replace. Okay, independent is with replace. I'm going to say or two unrelated events. Like maybe I'm spinning a spinner over here and I'm flipping a coin. Those two have nothing to do with each other, so they are independent. But I'm trying to find the probability of both of those things happening. So I'm going to multiply that. Again, I don't have to say that that's not replace, because they're spinning a spinner and flipping a coin. They're two unrelated things, okay? Versus dependent, you're multiplying the two fractions together, but you're subtracting from this number. Now, you may also be subtracting from the top number if they say, like, I want 2 sevens, right? So there are 4 sevens. Don't write this down. 4 sevens out of 52 to begin with. Then there's 51 cards, but there are only 3 sevens now, okay? So if you're doing the same card, you'd have to subtract from the top number as well. So I'm going to say maybe subtract from the top number. All right, let's do an example. Using this info down here, I'm going to try to zoom out. Let's say I am independent events. All right, I want to find the probability of a ninth grader and then a 12th grader. So my first person to be a ninth grader, I want my second person to be a 12th grader, okay? Oh, and I'm doing with replace. With replace, okay? So fraction times fraction, the word and, if you want to circle it, that tells you what you're doing. So I'm looking for a ninth grader first, and then I'm looking for a 12th grader second, okay? So ninth grader, there are 26 ninth graders out of 87. And my 12th graders, there are 19 out of 87. Okay, and I am replacing, so that means I still have 87 the second time I choose. All right, I'm going to zoom in on this. So ninth grader, 26 out of 87. 12th grader, 19 out of 27, or 19 out of 87. And I picked really crappy numbers because I have no idea if any of those reduce. I know 19 is prime. 26 is only 2 and 13. I have no idea if that reduces, and I don't know what that is. Let me just do some math here. Hold on. I have my stupid phone calculator. 26 times 19 is 494, and 87 times 87 is 7569. And if I divide 494, 7569. It is 0.065, so a 6.5% chance that that's going to happen, which is probably about accurate because, like, I mean, there's 87 students, so the chances that the first one's a ninth grader, second one's a 12th grader, that's going to be a kind of a low chance, but not terribly low, okay? All right, I'm going to do the same thing for the second one. Find probability of ninth, then 12th without replace. We'll just see what that looks like. Okay, 9th, then 12th, 9th, 12th, that fraction times that fraction. So the only thing that's going to change, there's still 26 out of 87 ninth graders. Now there are 86 kids. Do I have to subtract from this top number? Is that still 19 or is it 18 now? It is still 19 because we are assuming that when I wanted a ninth grader here, I did in fact choose a ninth grader. So that means there are still 19 12th graders, okay? And so I get a number and whatever that is. This is still 494, and that is whatever, 87 less than that. 87 times 86 now, 7482. I don't know if any of this reduced to begin with. Like I would usually try to cross reduce, but I don't know. Those are big enough numbers that I just kind of want to stay away from it. 7482. So my chance goes 0.066, so 6.6% chance of that happening. Slightly higher, but whatever. Okay, there's that. All right, and now we go to the adding. This is going to be the OR stuff, and this is where you add, right? You're adding probabilities instead of multiplying probabilities. All right, mutually exclusive events means that you have two events that are completely unrelated, so like they're separate. Inclusive means I have overlap. So like a king and a heart or whatever. I'm not going to write that down. King and heart, okay? So mutually exclusive means you're adding the probabilities together and that's it. Inclusive, you're adding the probabilities together, but then you're subtracting out this is the fraction that repeats. Okay, I don't know if you guys can understand this. Like this is my fraction bar. So I have a number here, number here, number here, number here, right? Number, you don't have to write this down. I'm just like showing you how this works. So these are all my numbers. Okay, so you're adding the two fractions together and then you're subtracting the third fraction. Whatever. The third one that you're subtracting is the part that repeats, which is the part that lives right here in the inclusive part. Okay. I'm trying to think of important info. I don't know if I have important info. What did I write down before? With replace, without replace. I don't know. Mutually exclusive. The categories don't overlap. Don't overlap. Categories overlap. Okay, I might also put over here in mutually exclusive and inclusive. I know that those are or, and that means that you are adding, but there is only one event, but multiple categories. So I'm only selecting one coin, but I might want to know if that one coin is a 7 or a king, right? So multiple categories, but only one card is being chosen. Here it is 2 or more events. Like over here, I was choosing 2 students, right? That's how I know I need to multiply. Okay, all right, I'll try to go through this a little bit faster. So categories don't overlap. So I want to know, find the probability of choosing one student and getting a 10th grader or a 12th grader. Okay, 10th or 12th. All right, so 10th and 12th have nothing to do with each other, right? Like you can't be a 10th grader and a 12th grader at the same time. So I'm only selecting one student. That means I'm adding. The chances of getting a 10th grader is 26 out of 87. The chances of getting a 12th grader is 19 out of 87. And when I add, I find a common denominator, which this one already has. And 27 and 19 makes 45 out of 87. And that actually divides by 3. I know that. That is 15 over 87 divided by 3 is 29. And 29 is prime. So that is the most reduced you can get. You could convert that to a decimal, but I don't care. Whichever format you want to put it in, okay? Now I'm going to go the probability of getting a 10th grader or a boy, right? So now we do have overlap because I do have some 10th graders that are also boys. So I need to add those two, and then I'm going to subtract out my middle people, okay? So I'm going to do this little diagram right here. All right, and I should have made my middle bigger, but that's fine. 10th graders, there are 26 10th graders. Boys, okay, so 10th graders is 26 10th graders. Boys, there are 40 boys total, right? But who's overlapped? These 10 people in the middle are overlapped because those 10 people are getting counted twice. They're getting counted over here in the 26 and over here in the 40. So I'm going to do 26 out of 87 plus 40 out of 87. But then I'm going to subtract 10 out of 87. Okay, because my 10 is my overlap. All right. Sometimes it's nice and easy to do 40 minus 10 first. So I'm just going to cancel those. I'm going to say that's 30. And then 30 plus 26. That is going to be 56 over 87. And 56 does not divide by 3. I don't know. That might be reduced. Not sure. I don't know. We'll just leave it like that. 56 over 87. I don't know if it reduces. I don't have a calculator. And I don't want to think that hard. All right, there you go. Good. So subtract out the middle when there is inclusive, people that live in the middle. All right. All right. Conditional probability. These are the given things. Okay. So probability of something given something. This means given. And you are going to start with the given. The given, I'll say given changes your bottom number. Okay, and kind of changes your top number. So I want to know the probability that I'm going to have I'm going to do 2 of them. Can I do that? I'm going to go to the probability of a 12th grader given a girl. And I'm going to find the probability of girl given 12th grader, okay? We've already established in another homework assignment that those 2 things are not going to be the same, right? Just because I flip them around doesn't mean they're going to be the same. In fact, they're very different, okay? So I'm going to do this first one. I'm going to have a top and a bottom. This one, I'm going to have a top and a bottom. So I'm going to do my fraction like that. All right, so 12th grader given girl. I'm going to start with the girls. That's going to be my new bottom number. I'm not looking at all 86 anymore, or 87 anymore. I'm only looking at the girls, right? Girls, there are 47 girls. So that's my new bottom number, 47, okay? Now, of those 47, how many are 12th graders? I have a lot of you that are still wanting to say 19 because that's how many 12th graders, but all 19 of these aren't girls. The only ones that are 12th graders that are girls are 8, right? It's saying of these 47 who are 12th graders, right? Only those 8. So 8 out of 47, whatever that comes out to be as a decimal, I'm just going to leave it as 8 over 47. Okay, so it's not 19 over 47, it's 8 over 47. Okay, all right. Let me erase some stuff, sorry. Okay, now if I flip it around, now I'm not looking at all 87, I'm only looking at the 12th graders. That's my new bottom number, so my 12th graders are 19. Okay, now how many of those are girls? Well, if you're trying to do that same logic before, a lot of you guys are putting 47 over 19. Well, that's not even a probability because the bigger number is on top, right? That would be like over 200%, right? That's not even going to work. So it's not 47. Of these 19, how many are girls? 8. So 8 out of 19. Okay? So you're given, you start with your given. I start like from the back and work to the front. I start with the given. The given is the new bottom number, that type of thing. Okay? So there is that. All right. Next, complement. Complement is usually the not. Okay? Like not something, right? What are the chances of not getting this? Okay, complement is usually not. All right, and I'm just going to do an example. I want to know the probability of not selecting a sophomore, so an 11th grader. Okay, what's the chances of not selecting an 11th grader? Okay, there are 16 11th graders out of 87. Okay, so probability of 11th would be 16 out of 87. If I'm wanting not an 11th grader, I just subtract that from 100%, right? 87 minus 16 is 71 out of 87. That would be the probability of not 11th. Okay, and those are complements. All right, I'm going to write some notation over here. P of A would be an event. P of A bar is going to be the complement. So sometimes they'll note those as, they'll use that as a notation. They'll say P of A and P of A bar. Okay, that's what a complement does. They add up to be 100%. So if I add these two together, that would end up being 100%. Okay? All right, that's what he looks like. Sorry for my messy table, and I know it's really disgusting. Okay, you have a lot of tables that look like this on this review. So that's what I want you to do right now, is to work through as much of this review as you can. Some of these are very, very easy, like number 9, evaluate the expression 8p4. Plug the dang thing into your calculator. And then it says explain what this means. So like I'm choosing this number out of this number, whatever, and does order matter, does order not matter? Explain that, right? Okay, I know that we don't have a story problem context to it, but just tell me how many you're choosing, does order matter, that type of thing, okay? All right, go through, this is a contingency table, so this is like your grid, do some totals over here, that type of thing. You'll need to do that. Go through and see if you can get, you should be able to get done with most of these, honestly. Yeah. Maybe these ones might be a little bit more confusing. Discuss the range. Well, no, that's not too bad. Try to do as many of those as you can, and then we'll go through any questions that you have on Monday. Okay, and we'll also do section 4-5. So get through as many of those as you can. I don't know how long I've been talking, but use the rest of the period to do those. Okay? All right, goodbye.